Motion of connected bodies. Suppose this is the ceiling. A pulley is connected with the ceiling with a rope. This is the rope. And there is another rope which passes through the pulley. And this rope connects two bodies of mass M1 and of mass M2. And we consider M2 is greater than M1. When such an arrangement is done with the help of a pulley and a rope and two bodies, the bodies are connected to each other with that rope or string, and this pulley is also connected with a ceiling, and these two bodies are free to move, then the motion of these two bodies is termed to be motion of connected bodies. And it is an important subject of discussion related to Newton's law of motion. So these are the primary data, M1 and M2, two bodies, and the bodies are moving under acceleration of gravity. So when the bodies are moving under acceleration of gravity, this body, particularly M2, M1, will move upwards and M2 will move in downwards direction. This is the motion of the direction of motion of M2, and this is the direction of motion of M1. Okay. And we consider the acceleration of this body is equal to A, and as the string is not stretchable. That means the length of the string remains unaltered during our experiment or observation. The acceleration of M1 will be equal to the acceleration of M2. This is also A. And we know the fundamental principle, the most fundamental principle of Newton's laws of motion, force acting on a body is equal to M into A, where F is equal to force acting on the body, M is equal to mass, and A is equal to acceleration. Now, considering the motion of mass M1, considering the motion of mass M1, force acting on M1, F is equal to M1 into A. So, what is the force acting on this body? The external force acting on M1. Now, for simplicity, if a body M, if a body M is kept under influence of gravity, it will be acted upon by a force M into G, and this force is always directed downwards. So, the mass of M1 will be acted upon by a force, and that force is equal to M1 into G. This is M1 into G. And similarly, this body M2 will be acted upon by another force, and that will be equal to M2 into G. Okay. Now there is another force. when a body, suppose there is a body here, it is being pulled by a rope connected with the body. This is the rope. And suppose the force applying agency is A is here. There is a force applying agency that is applying a force on this body with the help of a rope. Then a tension will be acted upon on this body along the direction of motion of the body. Okay. Or along the direction of the rope, the tension will be acted upon on the body. So another force, tension, and remember tension is always away from the body considered. So when this body is considered, the tension will be along the rope, and in this case also the tension will be along the rope but away from the body. In each case the tension is equal to T, this is T, and this is also T. Now consider M1. Considering the motion of mass M1, F is equal to M1 into A. F is equal to total external force acting on M1. So what is the total external force acting on M1? We know the total force acting on M1 is equal to, there are two forces, one is M1G and another is T, and under action of these two forces T and M1G, the body moves upwards. So T is considered to be greater than M1G. That means the net external force acting on this body is equal to T minus M1G. In place of F, we can write T minus M1G is equal to M1 into A. And this equation is equal to equation number 1. Similarly, if we consider mass M2, then M2G acts downwards vertically. Tension on the body applied by the rope acts vertically upwards, and as the body moves downwards, M2G is greater than P. So the net force acting on this body is equal to, or M2, or M2, M2G, this is greater than T. So M2G minus T is equal to net force is equal to M1. In case of M1, it will be replaced by M2, and this is A. And this is equation number 2. Now, if we add these two equations, we will get T plus T minus T will be cancelled. M2G minus M1G in this M1 plus M2 into A. So we can write here M2G minus M1G is equal to M2A plus M1. And this can be written as M2 plus M1 into A is equal to M2 minus M1 into G, or A is equal to M2 minus M1 into G divided by M2 plus M1. Now we had the equation, first equation. This is equation number 3. But the first equation was like this: T minus m1g is equal to m1 into a, or from equation number 1. T minus m1g is equal to m1a, or T is equal to m1a. In place of a, we can write m2 minus m1 by m2 plus m1 m1a plus m1 into g. So this is another g plus m1 into g. Okay. Now after simplification, we will get. You may simplify this, and after simplification, we will get, or t is equal to 2 m1 m2 g by m1 plus m2 and 4. This is the equation number. Now we have to consider the original diagram again, and this is the proof diagram. This is the ceiling, this is the pulley, and M1, and this is M2, M2 moving downwards, M1 moving upwards, tension, tension. Okay. Now we have to consider the pulley, only the pulley. So when we consider only the pulley, this is the number one, proof number one. This is a string. With the help of this particular string, the pulley is connected with the ceiling, and there are two ropes here. Actually, this is a single rope. This single rope passes over the pulley to connect two bodies. So this is single rope, but there are two parts of the rope. Okay. Now, when we consider the pulley itself, T acts along downwards. T acts along the downwards direction. Now consider or remember this fine difference. When we consider this body, tension is along upwards direction. T, T is the tension along upward direction. When we consider this pulley, same tension acts along downward direction. When we consider this body, tension is away from the body along the rope. When we consider this body, tension is away from the body along the rope. So there are two tensions. One is T, another also T. These two tensions are acting along the same direction. So these two tensions will be added, and the pulley is again considered to be attached with the ceiling with a rope, and another tension T prime or T1 will act on this pulley along upward direction. Okay. So when we consider the pulley, the net force acting on the pulley is equal to T1 minus 2T. Under action of these two types of forces, the pulley neither move upward directions or along the downward direction. It is fixed. That means the acceleration of the pulley is 0. That means mass, it may be m, and acceleration is equal to 0. That implies T1 is equal to 2t. And 2T means 4 M1 M2 G by M1 plus. So there are three equations. Number one expression for A is equal to M2 minus M1 by M2 plus M1 into G. For T, 2M1 M2 into G by M1 plus M2, and for T prime or T1 it is equal to 4 M1 M2 into G by M1. You must remember these three equations, and there are so many problems related to connected bodies or related to pulley and string, and these three principles will be applicable in context, and we have to determine the condition or the force of equation in judicious way depending upon the situation, and you have to wait to see the mode of expression or mode of solutions for different types of pulleys. Thank you for your view.